You're looking at a live view of a Falcon 9 rocket as it awaits liftoff from the SpaceX launch pad approximately 11 minutes from now at 33 minutes after the hour. Welcome to today's live webcast of the Hispasat 30W6 mission from one of my favorite pads, Space Launch Complex 40 at Cape Canaveral Air Force Station in Florida. My name is John Innsbrucker. I'm the Falcon Principal Integration Engineer. Today we will be delivering the Hispasat 30W6 communication satellite to a geostationary transfer orbit, also known as GTO. Now at 6 metric tons or 6,000 kilograms, Hispasat 30W6 is the largest geostationary satellite we've ever flown. It's almost the size of a city bus. We'll cover the Falcon 9 mission on today's webcast from now through satellite separation. The first stage will perform the programmed re-entry and landing burns, but we won't have coverage of those events. Due to poor weather in the Atlantic Ocean, SpaceX could not send the drone ship downrange, and we will not be recovering the first stage. Today's flight, unlike many of our recent launches, includes a new first stage. This is evidenced by the clean white painted exterior you can see on the rocket on the screen. Now, launch was originally planned for 25 February, but we stood down on that launch attempt to conduct additional testing on the fairings pressurization system. Following those tests, we fixed our problem, and Falcon 9 was ready to launch early morning on the 1st of March. But a previously scheduled Atlas launch required SpaceX to move the launch to this evening. Hispasat was mated to the Falcon 9 a week ago, and it rolled out to the pad and was raised vertical early Monday. Now, SpaceX uses a transporter erector to carry the launch vehicle the short distance from the hangar to the pad. The transporter erector then raises the vehicle to vertical. The erector is the structure that you can see to the left of the Falcon 9 rocket in the image. Now, the strong back part, the vertical part, will recline to about a 55-degree angle at liftoff, moving away from the Falcon 9. Now, the Falcon 9 you see on the screen is a two-stage rocket. The first stage has 9 Merlin engines. That's why we call it the Falcon 9. And it makes up about 2/3 the overall height of the rocket. Our original plan tonight was to recover the first stage in the Atlantic Ocean on our drone ship. But waves up to 8 meters, or 26 feet in height, eliminated the possibility of recovery, and we kept our drone ship, Of Course I Still Love You, in port. Now, the first stage will still fire its engines to re-enter and land, and you may hear some of that during the flight on the countdown net, but we don't expect the first stage to survive landing. Now, on top of the first stage is the second stage. It uses a single Merlin engine optimized to perform in the vacuum of space, and it will place Hispasat into a geostationary transfer orbit. And finally, if you look at the top of the rocket, that's our payload fairing that encloses the satellite. The fairing protects the satellite as we power through Earth's atmosphere and will separate along the middle at about 3 minutes and 30 seconds into flight. Now, this is a version 1 fairing, unlike the slightly wider version 2 we flew late last month from Vandenberg. T-minus 6 minutes, 45 seconds. We're starting to hear activity on the countdown net. We did our standard go, no go poll. That was held at about T-minus 2 hours. We began loading propellants at T-minus 70 minutes. Fuel is currently loaded on the second stage as planned, and we are finishing up the first stage. We are in the middle of about a 1-minute top-off that began 30 seconds ago, and we've just heard the call out. The stage 1 fuel load is complete. Liquid oxygen loading is continuing on both stages. That'll wrap up between the T-3 and T-2 minute marks. Hispasat's satellite team is go for launch. They confirmed at T-14 minutes they were on internal power. No further activities from here. The Air Force range is ready to support. The areas are cleared around Slick 40 for flight. The weather, both at ground level and upper altitude winds, is good and go for launch. So at all stations indicating go for launch, let's take a closer look at today's satellite.
We live in a hyper-connected world, surrounded by information, and with consumer habits that are oriented towards greater freedom of movement and a demand for increased flexibility, reliability, and capacity in communications. We need connectivity of the highest quality wherever and whenever needed, regardless of whether we are located in a remote area or we are moving at high speeds. To respond to this growing demand, Hispasat launches the Hispasat 30W6 satellite. From its orbital position at 30 degrees west, Hispasat 30W6 will replace and expand the capacity of Hispasat 30W4 and thus completes the current phase of the company's growth plan. Hispasat 30W6 has beams that point to the Mediterranean, Europe, Spain, Northeast Africa, and the American continent. And it increases the operator's Ka and Ku band offering, as well as incorporates a new beam in the C-band. With this configuration, Hispasat 30W6 will provide broadband internet access to help bridge the digital gap in North Africa, Latin America, and the Iberian Peninsula. Reinforce the distribution of audio-visual content in Latin America, and provide connectivity in high-speed trains and maritime services in the Caribbean and Mediterranean. Hispasat 30W6 is the fourth satellite of the Hispasat fleet built by Space Systems Loral on its 1300 platform, and it involved the participation of Spanish companies to manufacture components and develop the ground segment. Furthermore, Hispasat 30W6 incorporates a Ka-band receiver demonstrator based on photonic technology, and its modules have been designed by DAS Photonics and Trio. With services similar to those of the current receivers available on the market, the application of photonic technology to these types of components will make it possible to significantly reduce its mass and volume in the future. The launch of Hispasat 30W6 will be carried out on a SpaceX Falcon 9 vehicle from the Kennedy Space Center facilities in Cape Canaveral, Florida. From its orbital position at 30 degrees west, it will provide high-quality telecommunication services during its more than 15 years lifetime. Hispasat 30W6, growing connectivity.
T-2 minutes and 44 seconds. We're counting down to an on-time launch. Everything looks good on Falcon 9. First stage propellant load liquid oxygen has just completed. Second stage is wrapping up. The strongback has moved away the degree and a half from the Falcon 9. We're getting ready to pressurize for flight. Next activity at T-1 minute. The flight computer on the Falcon 9 will go into startup, taking over control of the countdown. The Hispasat satellite team, they are go for launch. The range is go. The weather is go for launch. And so now at T-2 minutes and 10 seconds, we're going to listen in to the last minutes of the countdown of Falcon 9 with Hispasat 30W6.
Stage 2 LOX load complete. Falcon 9 is on internal power. Vehicles in self-line.
Ground gas clear to start.
M1D fuel bleed complete.
AFTS is ready for launch.
M1D engine chill complete.
Ground gas closeout is complete.
Falcon 9's in startup. Stage 2 is pressed for flight.
LD is go for launch.
Falcon 9 is configured for flight.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff.
Vehicle is pitching downrange.
Stage 1 propulsion terminal.
Power telemetry. Vehicle is supersonic.
We're just over 1 minute into flight. Falcon 9 is passing through the period of maximum dynamic pressure.
Vehicle is experiencing max Q.
You've heard the call out. We're now experiencing maximum dynamic pressure, where the velocity of the first stage and the density of the Earth's atmosphere combine to create the greatest loads on the rocket. We're through that period. Merlin engines have throttled back up to full power. Propulsion indicates nominal. Power and telemetry also reported nominal. Next major activity, just a little under a minute from now, we'll have the main engine cutoff, followed by stage separation and ignition of the second stage engine. T plus 2 minutes into flight. We've got about another half a minute left in the first stage burn. Trajectory looks good. We're going right down the middle of the track. We've got a great view from the ground looking up at the Merlin engine plume on the Falcon 9. Main engine cutoff of the 9 Merlin engines in about 10 seconds.
Eco.
Stage separation.
Recognition.
Coming up on 3 minutes into flight, you hear the applause here from SpaceX headquarters in Hawthorne, California. We've had a good first stage shutdown, a stage separation, and a good ignition of the upper stage engine. Right after ignition, you may have seen a couple of pieces of metal coming off the nozzle. That's normal. Those are stiffeners that go around the bottom of the nozzle for use in transporting on the ground. They fall off as we go into flight. Next event coming up in about 10 seconds, we're going to wait and watch for fairing separation.
Second stage is following nominal trajectory.
Fairing separation confirmed.
Again, the applause. You saw a good payload fairing separation. The fairing separating into the two halves and falling away. We're coming up on 4 minutes into flight. GNC reports trajectory is good.
Acquisition of signal, Bermuda.
Acquisition of signal Bermuda indicates that the Falcon 9 telemetry is also being acquired by our ground tracking station in Bermuda. Upper stage engine power continues to be constant. Thrust to the Merlin Vacuum D engine is good. We're coming up on T plus 5 minutes into flight. Looking at the trajectory map, Falcon 9 continues to go right along the planned path, heading east from Cape Canaveral into the first of 2 orbits planned for this evening. Now currently, we're planning to burn that upper stage engine for just about another 3.5 minutes. We may also hear call-outs in a little more than a minute of entry burn. The first stages I mentioned